Hi, this is Alex from devstories.eu, Learning DSPy, Episode 4 of 15. Usually when you want a language model to reason through a problem, you resort to hacking strings together, haphazardly appending phrases like think step by step to your prompt. You tangle your application logic with fragile text instructions. In DSPy, prompting techniques are not strings. They are structured, swappable components called modules. It is easy to confuse modules with signatures. Think of a signature as the contract. It defines the what, mapping specific input fields to specific output fields. A module defines the how. It is a parameterized, callable object that takes your signature and applies a specific prompting strategy to fulfill that contract. The most basic module is the Predict module. You initialize it by passing your signature as an argument. If your signature asks to turn a document into a summary, the Predict module handles the prompt formatting and calls the language model. But maybe the task is complex and requires intermediate logic. You can easily swap Predict out for the Chain-of-Thought module. You do not change your signature. You just pass it to the Chain-of-Thought module instead. Under the hood, this module automatically modifies the prompt architecture. It instructs the language model to generate a step-by-step reasoning trace before producing the final output fields you defined. When you call the Chain-of-Thought module with your input data, it returns an object containing your requested outputs. Because you used Chain-of-Thought, that object also includes a new field containing the model's rationale. You can inspect exactly how the language model arrived at its answer, separated entirely from the final extracted value. Here is the key insight. You can nest these built-in modules to create complex programs, much like you would stack neural network layers in PyTorch. We can build a multi-hop retrieval pipeline to see this in action. You start by defining a custom class. In its initialization phase, you declare the smaller modules you will need. For a multi-hop architecture, you might declare a query generator module using Chain-of-Thought and an answer synthesis module using standard Predict. Then, you define a forward method to route data between them. The forward method takes an initial user question. It passes that question to your query generator module, which outputs a search query. You execute that search against your database to retrieve a document. If you need a second hop, you pass the retrieved document and the original question back into the query generator module to produce a more refined search query. Finally, you pass all the retrieved documents and the user question into the answer synthesis module to generate the final response. You have just built a custom executable graph out of modular components. When you chain multiple calls together like this, it's crucial to see exactly what is being sent to the model behind the scenes. DSPy tracks your language model usage globally. You can call the inspect history command on your language model object to print the most recent interactions. This renders the exact string the model received and the exact string it generated, ensuring your composed pipeline is assembling the context correctly. By separating your task definition into signatures and your execution strategy into parameterized modules, you transform prompting from a text editing chore into an architectural decision, allowing you to upgrade your pipeline's reasoning capability simply by swapping a class name. Thanks for listening. Happy coding, everyone!